Hi children, in our previous class I have explained about graph and also I have mentioned that motion can be represented graphically, right? And today we'll see some graphical representation of a moving object. That is the position time graph I will be explaining first. So in that, as I told you, there are two axes, x-axis and y-axis in the graph, isn't it? And in both these axes, we will represent each of these physical quantities, that is position and time. So, in position time graph, we will take time on x-axis, which is an independent quantity, and position, which changes with respect to time, that is dependent quantity, we will take on y-axis. So position on y-axis and time on x-axis. So let us represent position time graph, position and time of a moving object graphically now. So listen carefully, watch the video carefully. For that, I have written some values of time and position as a chart here. So listen, here x-axis, I have mentioned here, x-axis time is written in seconds, and that is 0 second, 1 second, 2 second, 3, 4, 5, 6 seconds, and position of the object is taken in meters. At 0 second, the position is 0, 1 second, at 2 meter, the position is representing in meter here. So 0 second, 0 meter, the object covers 0 meter, and at 1 second, the object is at 2 meter from the origin. These all are from the origin. So 2 seconds, the object is at 4 meters. At 3 seconds, object is at 6 meter. At 4 seconds, it is at 8 meter. 5, 10 meter. 6 seconds, it is 12 meter, etc. So here you can see at 0, time is in second, position is represented in meter. So at 0 second, the object is at 0 meter, that is at the origin itself, and at 1 second it is at 2 meter, at 2 seconds it is at 4 meter, and 3 seconds it is at 6 meter, 4 seconds it is at 8 meter, 5 seconds at 10 meter, and 6 seconds at 12 meter. So these values, this observation we have to write it on the graph, represent in a graph. So let us do it. For that I have taken a graph paper here, and I will draw both the axes on the graph paper. Then we can represent this time and position on the graph paper. So let me draw x-axis and y-axis graphically here. Here you can see I have drawn y-axis first, and then let me draw x-axis here. So I will draw x-axis here by using scale. I got an x and a y-axis. You can see both the axis, x-axis, this is the origin. I will represent it as O, and here I can write it x-axis, and here it is y-axis. Now we have to mark the points. At here 0 to this darker line in the graph, each darker line in the graph represents 1 unit. So each darker line represents 1 unit. This 1 unit on x-axis we have to take time. So time should be taken on x-axis. So I will write here time in seconds here. So this represents seconds. Okay. So each unit represents seconds. So next, this line on the y-axis, this units represent the position in meters. These units represent position in meter. Now let us mark the points here. 0, here after that 0, 1 second, 2 second, 3 second, 4, 5 and last one 6. Here I will take 0, 2, 4, 6, 8 and last 10 I took here. Okay children, now you can see in the graph I have marked 0, 2, 4, 6 here on the y-axis 0, 1, 2, 3, 4, 5, 6 I took. So this 1, 2, 3, 4 all are seconds. 1 second, 2 second, etc. And here 2, 4, 6 all are in meter. So 1 unit, here each unit, this distance between this darker line is unit, 1 unit. So each unit in x-axis, on x-axis represent 1 second. So from 0 to 1, this darker line it is 1 second. From next, from here to next darker line 1 second. So the gap between the difference between each unit should be equal. So the difference should be equal in between each unit. So on x-axis we can say 1 unit represent 1 second here. X-axis 1 unit represent 1 second. And on y-axis 1 unit means here you can see 0 and here the next darker line represent 2 meter. And from this darker line to next dark line it is again 2. After 2 we wrote 4. So this 2 to 4 it is 2 meter distance, isn't it? And the next unit represent 2 meter difference there. So this way equally distributed. Okay, so the difference should be equal on y-axis also while writing the numbers on x and y-axis. So here we got 2 meter, 2 meter. Even 1 unit on y-axis represent 2 meters. So this is called scale of the graph. This is called scale of the graph. So we can write the scale as, so we can say for drawing this graph, we have taken the scale as x-axis 1 unit is equal to 1 second and y-axis 1 unit is equal to 2 meter. This is the scale we have taken to draw this graph. Let us see how to mark the points on this graph. So to represent this graph points we have to mark on this. So first time, at 0 time the object is at 0. So the position of the object we can represent here, mark here. Then at 1 second the object's position is 2 meters. So draw a perpendicular line here and 2. So first go straight upward and from 2 horizontally. So both meet at here. So the second point we got here. Now the next point 2 to 4. 2 time is 2 seconds and the object is at 4 meter. So 2 seconds the object is at 4 meter. So go straight from 2 seconds at 4 straight 4 seconds. So here it is. Then at 3 it is 6. So this way we have to mark the points on the graph. So at 4 we got 8 on the question. The question it is given that you can see the questions here. At 2 4 seconds, 3 6 meter, at 4 seconds 8 meter, like that. According to that we have marked the points here. 0 at 0, 0, 1 second the object is at 2 meters and at 2 seconds thus go straight up to 4 and then we mark the point here. For 3 seconds go straight up and along 6, horizontally 6. So here we got the point. So all the points we got. Now join all these points. So we'll get a straight line. All these points are in a straight line. You can see the graph we obtained is a straight line graph. So the object if moving in a uniformly, the motion represent uniform motion is the graph is a straight line for a uniformly moving object. So what all things we can understand from the position time graph? First of all, we can understand the position of the object at a particular time. Here you can see at 2 seconds, what is the position of the object? At 2 seconds, go straight up, reach at the graph, and you can see the point here, the straight up line from the 2 seconds. It meet at a point on the graph, the straight line or straight line, and from the point draw a line towards the y-axis. That is the position there. The point, whatever value is there, that value will give the position of the object. So we can obtain the position of the object from the graph. The time taken by the object to travel a particular distance also we can find out from the graph. The time taken to travel a particular distance also can be find out from the graph. So to cover 2 meters. So here you can see from 2 to 4 meter. 4 meter means 2 meters it covered. So to cover 2 meter, how much time it took? So draw a perpendicular to the x-axis from 4 seconds. Here from here also you draw. So how long it took? 1 minute, 1 second only, 1 to 2 seconds. So 1 second it took. So from the time taken by the object to travel a particular distance also can be find out from the graph. We can find out whether the motion is uniform or non-uniform. If the motion is uniform, I told you, the graph will be a straight line. So this much for today, children, and today you just revise from the textbook, and we will continue the portion in the next session. Until then, bye.